Hello everyone. So before we start solving pulley problems, let us first derive the moment of inertia of a disk. Because pulleys that have mass are treated as disks. So for example, here we have a disk with radius r. So you can imagine that this disk is actually a pulley and it is to rotate in this direction. So we are interested to find what is the moment of inertia of this disk. So this disk has radius r and it has a mass, say m, capital M. So the moment of inertia of this disk, or if of any object, is defined as I equals integral of r squared times dm. Okay, so first we need to find what is the differential mass dm. So in order to find an expression for dm, we know that we can define, say for example, we have a differential mass here occupying a certain differential volume. We can define its density to be the small mass over the small volume. So this is sort of like the mass per volume. So solving for dm, we have density times dv. But we know that v of a cylinder is pi r squared times h. So we get the differential volume with respect to r. We would get 2 pi r h times dr. So now we have dm to be equal to rho times 2 pi r h times dr. So we will be substituting this expression for dm here. So we get I equals r squared times rho times 2 pi r h times dr. So now we can integrate with respect to r, because earlier this r cannot be integrated with respect to dm. So that is sort of our goal, to express dm in terms of r. Okay, so let's move out the constants out of the integral. So we would have rho 2 pi r h, sorry, r is not a constant, so this will be 2 pi h times integral of r cubed dr. Okay, so before we perform our integration, let's see what is rho here. So rho is actually defined as the total mass. We can also define it as the total mass over the total volume of our cylinder. So our total mass is just m, and the total volume is pi r squared h. So we substitute this rho in yellow to our moment of inertia. So now we have m over pi r squared h times 2 pi h integral of r cube dr. So let's see what we can cancel. We have a pi, and h here. So we have here equals m over r squared. So we have a factor of 2. And then integrating r cubed dr, we have r to the 4 over 4. So we will be left with 1/2 m r squared, which is the moment of inertia of our disk.